Hi guys! Welcome to Science Moment, a place to ask the big questions, to seek the hidden truths, and to marvel at the sheer scale of the universe we call home. Ever since humans first gazed up at the night sky, questions about the origin and scale of the universe have haunted our minds. We are living in a golden age of astrophysics, where theories of the Big Bang, cosmic inflation, and dark energy are no longer mere philosophical speculations but have been bolstered by empirical evidence. This article will journey through a 13.8 billion year timeline, from the moment before time began to the distant future of an endlessly expanding universe. Chapter 1. The Paradox of the Beginning. What was before the Big Bang? 1. The concept of absolute nothingness. In common thinking, we consider nothing to be a vacuum. But in cosmic physics, nothingness is even more profound. It is a state devoid of matter, space to contain it, and time to identify events. Some hypotheses suggest our universe is a quantum dream arising from a random fluctuation within an eternal nothingness. According to quantum mechanics, the uncertainty principle allows energy to be borrowed from the void for an extremely short duration. If the total energy of the universe, including the positive energy of matter and the negative energy of gravity, equals exactly zero, then the universe could have been born without violating the laws of conservation. 2. Stephen Hawking's perspective and the North Pole. Stephen Hawking once proposed a famous analogy to answer the question, what was before the Big Bang? He suggested that time and space are conjoined into a single entity called space-time. As we go back into the past, space-time curves and closes off at the Big Bang point. Asking what was before the Big Bang is like standing at the North Pole and asking which way is north. The answer is, there is no more north, because north begins right there. Chapter 2. The Era of Inflation and the Big Bang. 1. Cosmic inflation. Before the universe was hot and dense as we typically know it, it underwent a phase called inflation. This was a process of expansion at a terrifying speed, many times faster than the speed of light. Speed. In a fraction of a billionth of a second, the universe increased in size by millions upon millions of times. Result: inflation flattened space and made the temperature of the universe uniform in every direction. Without inflation, our universe would be chaotic and unable to form stable galaxies as it does today. 2. The end of inflation and the Big Bang. When the inflation phase stopped, a massive amount of energy was released and transformed into a soup of hot elementary particles. This is the moment the Big Bang actually occurred in the traditional sense, an explosion of temperature and pressure, from which matter began to be created. Chapter 3. The Formation of Matter and the First Light. 1. The battle between matter and antimatter. In the first few seconds, the universe was a battlefield between matter and antimatter. For every billion particles of antimatter created, there were 1,000,000,001 particles of matter. As they annihilated each other, that tiny leftover fraction became all the stars, galaxies, and humans we see today. 2. The recombination era and the cosmic microwave background, CMB. For the first 380,000 years, the universe was like a thick fog of charged particles that prevented light from escaping. As the universe cooled to about 3000 K, electrons began to combine with nuclei to form neutral hydrogen atoms. Light is released. Instantly, the universe became transparent. The first photons, light particles, began their journey through space. Evidence. Today, we still observe this afterglow as the cosmic microwave background, CMB. It is the oldest map of the universe's appearance when it was still an infant. Chapter 4. The Unimaginable Scale of the Universe. 1. From the solar system to superclusters to understand the size of the universe. Let's start with small numbers. Earth-Moon distance, 384,000 kilometers. It would take 160 days by car driving constantly. Earth-Sun distance, 150 million kilometers, 1 astronomical unit, AU. Light takes 8 minutes and 20 seconds to travel this distance. Milky Way contains about 200 to 400 billion stars and has a diameter of about 100,000 light-years. 2. The Laniakea structure. The universe is not distributed randomly but clustered into filaments and clusters. Our Milky Way is located within a giant supercluster named Laniakea, Hawaiian for immense heaven. Laniakea contains about 100,000 galaxies and stretches across 500 million light-years. 3. Why is the observable universe 93 billion light-years wide? Many wonder, if the universe is only 13.8 billion years old, how can we see objects at a distance of 46 billion light-years, total diameter of 93 billion? Explanation: this is because space itself is expanding. As a beam of light from a distant galaxy travels toward us, the distance between that galaxy and us has increased significantly during the light's journey. Chapter 5: Hidden Components and the Eternal Future 1. Dark matter and dark energy. We only see less than 5% of the universe. Dark matter, 27%, an invisible substance that does not interact with light but possesses strong gravity, helping hold galaxies together as they rotate rapidly. Dark energy, 68%, a mysterious force pushing space to expand faster and faster. This was the most shocking discovery of the late 20th century, as it was previously thought that gravity would slow the expansion down. 2. The end of everything based on the current rate of expansion. The most plausible scenario is heat death. Galaxies will move so far apart that we will no longer see any other stars in the sky besides the Milky Way. Stars will burn out, black holes will evaporate, and the universe will become a cold, dark, and empty place forever. Conclusion: the universe is a problem where every time we find a solution, we face even larger questions. From a point smaller than an atom, through the process of inflation and billions of years of evolution, it has created beings capable of questioning their own origins. We may be small in physical size, but our ability to comprehend the vast scale of the cosmos is a testament to the power of human intellect.